all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this video, let us see about TCP IP model. The TCP IP protocol suite was developed prior to the OSI model. Therefore, the layers in the TCP IP protocol suite do not exactly match those with the OSI model. The original TCP IP protocol suite was defined as having 4 layers: host to network, internet, transport, and application. However, when TCP IP is compared to OSI, we can say that the host to network layer is equivalent to the combination of the physical and data link layers. The internet layer is equivalent to the network layer, and the application layer is roughly doing the job of the session, presentation, and application layers, with the transport layer in the TCP IP taking care of part of the duties of the session layer. We assume that the TCP IP protocol suite is made up of 5 layers: physical, data link, network, transport, and application. The first 4 layers provide physical standards, network interfaces, internetworking, and transport functions that correspond to the first 4 layers of the OSI model. The 3 topmost layers in the OSI, however, are represented in TCP IP by a single layer called the application layer. The major design goals of this model were to connect multiple networks together so that they appear as a single network, and to survey after partial subnet hardware failures to provide a flexible architecture. So this is a diagram which shows about the relationship between the OSI and the TCP IP model. So it has physical layer and the data link layers together. They are known as the underlying LAN and WAN technology. The network layer deals with the internet protocols and some other protocols. Transport layer deals with the several transport protocols, and the application layer takes care of the functions of session, presentation, application. So it deals with several application protocols. So this is the hierarchical protocol architecture of TCP IP, which is compared with the OSI model. So TCP IP is a hierarchical protocol made up of interactive modules, each of which provides a specific functionality. However, the modules are not necessarily interdependent, whereas the OSI model specifies which functions belong to each of its layers. The layers of the TCP IP protocol suite contain relatively independent protocols that can be mixed and matched depending on the needs of the system. The term hierarchical here means that each upper layer protocol is supported by one or more lower level protocols. At the transport layer, TCP IP defines 3 protocols, which are transmission control protocol, user datagram protocol, and stream control transmission protocol. At the network layer, the main protocol defined is the internetworking protocol. Apart from that, we have ICMP, IGMP, RARP, and ARP. So we will see each layer separately. So physical and data link layers. TCP IP does not define any specific protocol. It supports all the standards and proprietary protocols. A network in a TCP IP network can be a local area network or a wide area network. Next one is the network layer. So at the network layer, TCP IP supports the internetworking protocol, which is known as IP. So this IP in turn uses 4 supporting protocols, which are ARP, RARP, ICMP, and IGMP. Each of these protocols is described in future videos. Internetworking protocol. The internetworking protocol is the transmission mechanism used by the TCP IP protocols. It is an unreliable and connectionless protocol, a best effort delivery service. The term best effort means that IP provides no error checking or tracking. If IP assumes the unreliability of the underlying layers and does its best to get a transmission through to its destination, but with no guarantees. IP transports data in packets called datagrams, each of which is transported separately. Datagrams can travel along different routes and can arrive out of sequence or be duplicated. IP does not keep track of the routes and has no facility for reordering the datagrams once they arrive at their destination. The limited functionality of the Internet Protocol should not be considered as a weakness. However, Internet Protocol provides bare bones transmission functions that free the user to add only those facilities necessary for a given application and thereby allows for maximum efficiency. Let's see each and every protocol. First one is address resolution protocol. It is used to associate a logical address with a physical address. On a typical network such as LAN, each device on a link is identified by a physical or station address, usually imprinted on the network interface card. It is used to find the physical address of the node when its internet address is known. Reverse address resolution protocol allows a host to discover its internet address when it knows only its physical address. It is used when a computer is connected to a network for the first time or when a diskless computer is booted. Next one is Internet Control Message Protocol. Is a mechanism used by the host and gateways to send notification and datagram problems to the sender. It sends query and error reporting messages. Next one is Internet Group Message Protocol. Is used to facilitate the simultaneous transmission of a message to a group of recipients. The next layer is the transport layer. So it has two protocols, TCP and UDP. IP is a host-to-host protocol, meaning that it can deliver a packet from one physical device to another. UDP and TCP are transport level protocols responsible for delivery of a message from a process to another process. A new transport layer protocol, SCTP, which is Stream Control Transmission Protocol, has been devised to meet the needs of some newer applications. Hope you understood the TCP IP in detail. Let us take up some assessment questions. What layer in the TCP IP stack is equivalent to the transport layer of the OSI model? Yes, the answer is host to host. Which of the following protocols uses both TCP and UDP? The answer is DNS. TCP IP layer is equivalent to combined session, presentation and yes, of course, it is application layer. Thank you for watching this video.